Hello, I am Peter O'Connor, and today I plan to give a walkthrough of how to get a Amazon Sidewalk project up and running with our MCM dev kit pretty easily. I'm excited to just really jump into it. First, though, I do want to give a look at the dev kit and then just go over some of the features, and then from there we'll jump right into the application. All right, let's do it. So here we have it, the MCM dev kit. And MCM really stands for multi-connectivity module, and multi-connectivity in the sense that it can support Amazon Sidewalk, LoRaWAN, Bluetooth, Matter, and a host of other wireless protocols and technologies to support the IoT revolution, right? Or just interesting projects, really. So at the start of the show, MCM, multi-connectivity module, and it is running a special firmware that we created called NCP, or Network Coprocessor. And what this does, it allows this host platform, which in this case is an ESP32 Featherboard, to offload all the network complexities, such as, getting the stack right, what it takes to register with a network, and just do all the things that you really don't want to spend a lot of time working on. You want to work on the cool things, which is the business logic or the application logic. Let's go ahead and leave the network complexities and management up to the MCM, right? So that's what we're doing here. And in this case, in the example I'm going to show you, the ESP32 Featherboard will be running a code that's built on the Arduino IDE, right? So we're just going to make things really simple to get started with, really simple to modify, where you can start making new creations, no problem, okay? So along with this, we have an integrated onboard GNSS module, and this is useful for getting precision timing and location fixes, as long as it has a clear view of the sky, or a view of the sky in the sense that it can get a satellite signal and get a fixed position. Along with that, we also have an accelerometer, we have a temperature sensor, we have this neat quick connector, and this allows you to easily connect like smartphone dev boards, like new sensors, actuators, that sort of thing can be connected pretty easily and facilitate new functionality that, of course, with the application we're going to share, makes it pretty easy to connect it to Amazon Sidewalk. So we also have a battery connector, we have buttons and LEDs, we have a header for J-Link, so you can debug and flash your code on the MCM directly. And that supports host mode. We won't really get into the details of that, but host mode is essentially you can run your entire application and network and everything on the MCM itself without using another processor, right? So that's host mode. So this allows you to flash the firmware for host mode if you wanted. And then we have a tag connect connector here, which essentially does the same thing, just a simplified pin connector form factor. And then you'll see a host of header slots, and this allows it to essentially be flexible in the platform that you connect to, that you want to stack onto, connect it to, that sort of thing. So in this case, we're using the ESP32 Feather, but it could just as easily be an Arduino board, could be a Nucleo board, a Raspberry Pi, a Silicon Labs dev board. Your options are there as far as what you want to connect it to, making it easy, making it nice and neat, compact. We have the flexibility there to support a host of different platforms. So this is kind of the high level. Oh, right, we almost missed it. It has some built-in, hole mounts in the PCB that supports an off-the-shelf enclosure that we've designed this for. So that way you can take your prototype, your fresh, awesome thing that you've created, and wrap it up in a nice enclosure and take it outside and really show it off. Okay, so you can take it from development board to prototype in no time. So that essentially covers, for the most part, the dev kit and its features. We can go into the software on another stage of all the cool things that we've implemented, like firmware over-the-air updates and that sort of thing. But for now, we're just going to focus on the simple example. So you'll also notice that there's some cables coming off the side here. This one is a serial to USB adapter cable. And it's a little embarrassing to say, but we actually ran out of the newer versions of these boards that actually just you can connect it directly to the USB-C. So they gave me this to work with for this video, but nonetheless, it'll get the job done, so we'll be all good. But by the time we start shipping these things, of course, it'll be connected here, so don't worry about it too much. Then we have another cable for USB-C to the Feather platform. That way we can program the ESP32, get debug logs and that sort of thing pretty easily, and also power the rest of the system. All right, so now that we've given the overview of this board and what's connected to it, let's go ahead and jump into the project, right? And see how we can take the project and start sending some data. All right, so here, this is the repo that contains the example project that lives on the host platform that allows it to interface easily with the MCM, where you don't have to worry so much about how to what kind of commands to send and when to send it. The application kind of takes care of abstracting all of that for you. Now, this is not public yet, still a private repo, but we're putting the finishing touches. We're making it a little bit, smooth out the rough edges a bit, getting it ready for release. But once it is, of course, we'll give an announcement, and then you'll be able to do the same steps you're seeing here as far as getting your application going. Right, so not going to go into the details, but there's a lot there, and it'll dive into far more than I'm willing to spend some time on right now. So instead, let me show you the code. Same here. I'm not going to go into the details of the code. I just want everyone to see how quickly we can get up and running. So instead, I'll just give a super quick flyby just to see that this is an Arduino sketch, not many lines of code. So it shouldn't be too daunting as far as getting in there and making some modifications, doing some really interesting things quickly. Okay, so this code is actually built in such a way that we can just zip it up and import it directly into an Arduino IDE as a library, and we'll do exactly that right now. So clearly I have been testing. So we can start from scratch. Here we go. We will go ahead and import the zip library, but before that, let me grab the path. Save us some time. And the file's already zipped up, so I'll go ahead and grab it, import it, and yes, I have been testing, so it already exists. We'll just overwrite that, no big deal. And just like that, library is installed. So from there, let us open the example. It's built in here, and we're going to choose MCM LoRaWAN. Now, Oxit does a lot of LoRaWAN projects, so by default, when we're making this example, it starts out being a LoRaWAN device first. But there's an interesting trick. So the NCP firmware actually switches between LoRaWAN and Amazon Sidewalk every few uplinks, just to demonstrate the dynamic switching capabilities. But for now, it starts in default LoRa. So let's go ahead and change that to the default Amazon Sidewalk. Saves ourselves some time here as we demonstrate the messages being reflected on the portal for Amazon. So here we go. So at this point, I could build and flash the board, but there's actually one more important step that we have to do before we get into that point, and it's about the device's identification. So to identify itself as a unique device on the Amazon portal, the Amazon network, Amazon Sidewalk network, and application, you're going to have to give it an identity as well as some security credentials that will allow it to participate in the network and forward and receive traffic and do it in a secure way so your data is not compromised. So for that, we have to provide what we refer to as a manufacturing file, MFG for short. So before I do that, I just want to show you something else. So I mentioned that we have this serial to USB interface, and the reason why we have this is so that we can actually send the manufacturing file to the MCM manually, right? So you don't actually have to worry about using a debugger probe or anything like that to flash the file directly. You can actually just pass it serially. So that's the point of having this cable, and we'll do exactly that right now. And we'll show you how easy that is. So of course, let's just say the file is already there. In another video, a more in-depth topic, we can go into how we create the manufacturing file. But for now, we have it, so we'll use it. And the serial transfer protocol that I mentioned we're using is XModem, and we built it so that it accepts binary files, so .bin, so we convert it from a .s37 to a .bin. I can run this command. I already have it, so I'm not going to, but that's what converts it from one to the other. Now we have it, so let us use it. And of course, I was testing prior, so we have some data. Let's go ahead and clear the screen, do a reset here, send a command. Now, just like that, it's ready to accept the manufacturing file serially. So let's do that. Send xmodem, let's browse, here it is, select, send, and there it goes. And just like that, pretty quick. So now our board has an identity and it has a secure credential, so it can actually participate and join the network. So we can actually show off the demonstration that we have here. So we go back to code. And at this point, it's going to default to Amazon Sidewalk, and we have the manufacturing file installed. So let's go ahead and compile the code and flash it on the ESP32 Feather platform. Oh, first, select the board, of course. Now we do that. Okay. And we wait just a bit. It's quick, but takes just a little bit of time. It was already compiled, and now it's flashing the firmware. And here we go. We are seeing some logs. Logs are basic for now. Again, a part of just kind of getting things ready for a public release. We'll clean up just a bit more, but you'll have some indication as to it starting up, what's the version that's running, and it'll show you as it tries to send a message and that sort of thing. So here, you're rolling with me. Normally you wouldn't see this or wouldn't really need to, but this is under the hood of the MCM, the logs directly. And after we had uploaded the manufacturing file, you can also see it now trying to register to the network and being able to facilitate some uplinks. So that's there. And we can see that it's trying. Just give it a second here to send another one. And next is, take my word for it, it's working. No, I'm kidding. All right. So how do you know it's working? It says that it's sending the message, but you can confirm it by just going to Amazon and going to IoT core service. This is the device that we're looking for specifically, and it matches the name that I gave it here for the manufacturing file. So this is the one that we're looking for. And then we're going to look at the uplinks using the MQTT test client. So yeah, so let's look to see what happened. Sending another packet now. And it said it was sent successfully. So we should be able to tell. Let's go ahead and check. Oops, not that. Copy here, paste. And that was the most recent message. You can see the timestamp, 2:45, and same time as far as the message came through. So there we have it. We have payload showing up on Amazon's Amazon Sidewalk network via the device, and all it took was a few clicks. So I just wanted to show you how easy it was. That's it for the walkthrough. I am very excited about this and the possibilities and all the different projects that will result from this. Again, our job is to make this easy for those that want to use technology and get involved. And I am happy to have a discussion. Send some messages in a comment, or send me a message directly on LinkedIn, or check out our website for more information. And I'd be happy to explain, educate, discuss, geek out, all of the good stuff when it comes to Amazon Sidewalk and some of the interesting IoT technologies that are out there. So thank you for tuning in. This has been the walkthrough. And yeah, drop a comment and thank you.